Good morning, class. I hope everybody's doing good out there and staying safe and having a good time at home. And I hope you're learning a lot. And today we're going to be looking at concept number 2 from that concept inventory I gave you, classify triangles using given sides. So this is the idea. If I'm given 3 sides of a triangle, like suppose I'm given these 3 sticks and I want to make a triangle out of it, could I tell whether it's right, acute, or obtuse? So let me just arrange these 3 sides in a certain way. Doesn't matter. I'm going to put them together. And it looks to me like that might be a right triangle. You could compare that to a right angle. Maybe that's a right angle. But anyway, so if it is a right angle there, then I know that the Pythagorean theorem will apply. So I'm just going to say, a squared plus b squared equals c squared means it's a right triangle. So that's what we have. Now, sometimes you're given another side that's not a right triangle. So let's suppose I was given this side instead of this side. Now, in this case, this long side is going to just be a bit longer, and it's going to be an obtuse triangle. Now, that angle is now obtuse because this one stretched out and made this longer. So in this case, a squared plus b squared is less than c squared. The c squared, being the longest side of the triangle, would be too big, and this means that c is on the big side of that inequality, so it's obtuse. If we took a smaller side, like if this was just too small, then we probably have an acute triangle. Now this is still the longest side, so I really have to look at the longest side is too short to make a right triangle. And if it was a little bit longer, it would be right, but this is too short. So a squared plus b squared is greater than c squared. Notice that c, being the longest side, is too short, and it's acute. Okay, now notice that c is the longest side, so c must be the longest side. And you're making a determination whether the longest side is just right to make a right triangle, is too big to make a right triangle, or too small to make a right triangle. And that's it. So let me just draw this picture here. So I have some triangle, and I determined that one side is the longest. Let's call it C. And the other two sides would be A and B. So remember, this is the longest side. And you just plug it into the Pythagorean theorem, you make this determination. However, it does kind of lead to one problem, though, because if I'm given like these two sides, A and B, what if I was given another side and it was just too long? Like, you might calculate this, and it might end up being the obtuse triangle, like, because c squared is certainly bigger than a squared plus b squared. But notice that in this case, I can't really make a triangle with these lengths because they don't reach. Like, this long side is just too long to even make a triangle. So let me just make a note about that. If you get an obtuse triangle, it may not be a triangle at all, or it may not be possible. And so what are we going to look at here is this side, this long side C, and I'll draw another picture here. This long side C and this A and this B. As we can see here that A plus B must be greater than C. So A plus B is greater than C for any triangle. So if you get that as not true, then you definitely don't have a triangle. It's not possible. Okay, well, let's look at just an example. What if I'm given three sides of a triangle and I want to find out what kind of a triangle it has? So here's a couple of examples. My three sides, so this is 3 inches and 9 inches and 7 inches. Okay, so that's it. So those are my three sides. And first of all, I want to determine, well, I could start off by answering this question, because if it's not a triangle, then I don't really want to go on. So let's make sure that 3 plus 7 is greater than 9. The two shorter sides have to add up to be greater than the longer side. So that means 10 is greater than 9. So this is true. So it's a possible triangle. So I'm going to go ahead and go through my other part here where I plug it into a squared plus b squared. And I'm going to compare that to c squared. I just like to use the comparison symbol there. So anyway, so I have a 3 squared plus 7 squared. Those are my two shorter sides. And my longer side is 9 squared. And so that would be 9 plus 49 compared to 9 squared is 81. If I add these together, I get 58 compared to 81, and it goes this way. So what does that mean? Well, let's go ahead and look to make sure. Now, C is my longest side over here, and C is on this side of the inequality, which means that if you remember the teeth eat the bigger fish, or however you remember that, this is too big. So this long side's too big for a right triangle, so it's an obtuse triangle. So that's how I make it determine whether it's right acute or obtuse. I already determined that it's a triangle. If I didn't do that first, I'd say, well, an obtuse triangle, that C could be way too big to make a triangle. I just have to make sure that the two shorter sides, 3 and 7, have to be able to be long enough to go across the 9. So let me draw a picture of this triangle. If I had 3, 7, and 3 plus 7 is 10, it should be able to expand this 9, and it's going to look something like this. I hope this helps with this concept, classifying triangles with given sides. Have a great day, and so long.